Number 57, we'll do the same thing as before. In this case here, g is a reciprocal function. So when I differentiate differentiate d, I'm going to need to use the quotient rule. So I'm going to differentiate 1, which is 0 times g, minus 1 times the derivative of g, and that's all over the g squared. Okay, there's my quotient rule. Now 0 times anything, I'm just going to simplify this. 0 times anything is 0, so I get negative g prime over g squared. If I want to evaluate the derivative at x equals 1, I'm going to need to have the negative of g prime at 1, and then I need the value of g at 1 and square it. Okay, so then I go back to my table. At x equals 1, I need my two g values, g and g prime. So g is 3, g prime is negative 3. Okay, so I'm just going to remember that. G is 3, g prime is negative 3. So it's going to be negative of negative 3 over 3 squared. So I end up with positive 1/3. So my derivative value is positive 1/3. And just double checking, g was 3 and g prime was negative 3. G was 3, yeah, and g prime was negative 3. So there it is. So then I can apply the same principle again for 58. H is going to be an embedded function. So if I want to find h prime of 3, I need to differentiate h. So h prime is going to be 1/2 f of x to the negative 1/2. This is an embedded function, so I need to multiply by f prime of x. Okay, so there's my derivative using chain rule. I differentiate the outside first, then the inside. Remember that I don't change the inside function there. I'm just going to rewrite this as f prime of x over 2 square root f of x. Okay, so there's my h prime function. H prime at x equals 3 means I need f prime at 3, and I need the f value at 3. So now I go back up to my table, f prime at 3 and f at 3. F prime at 3, x equals 3 was 4, f was 10, so f prime was 4, f was 10. Okay, so f prime was 4, the f value was 10, so there's my slope at h prime, or h equals 3. And really I should simplify this to 2 over root 10, and so the answer is going to be D.